Okay, starting day 3A parametric equations. Now, we touched on this way back in what we call the first unit, the prerequisite unit. When in unit 1, it was one before that, unit P, I believe it was called. We talked about parametric, and the definition is the graph of the ordered pair x and y, where x is given to be one function, f of t, and y is to be given a different function, but in the same variable t. So you put 1t, you plug it in this function to get the x coordinate, you plug it in that function to get the y coordinate, and that tells you where to plot them. So those are functions defined on an interval of t, and that's what makes up a parametric curve. The equations are parametric equations for the curve, and the variable t is the parameter, and I is the interval. So basically there is a way a lot of times to make it a function that we know of, but this can make it easier to understand some things in physics. We look at the x coordinate and the y coordinate with things in motion, things going through the air. So a parametrization of a curve consists of the parametric equations and the interval of t. Now, this would not take long to do it by hand, but we're just going to speed things up and try to not do it by hand so much. Because if I wanted to find this from -3 to 1, I could plug in -3 into here. -3 squared would be 9, 9 minus 2 is 7. So x would be 7 would be x coordinate. Plug in -3 here would be -9. So 7 comma -9 would be my first coordinate. Plug in, and we could do whole numbers. It would kind of be a choppy line, but if we do interval, kind of do by tenths, instead of plugging in 1, plug in, -3, plug in -2.9 and -2.8. It would be getting smoother and smoother and smoother of a curve to see all those. Well, let's let the calculator do all that, though. So the calculator is going to make it a whole lot easier. So the first thing to do, because right now we hit y equals, and these are for normal functions, functions in one variable. What I need to do is push mode, move this up, so push mode, and go down and change this from function into parametric. So click parametric, and we hit y equals. Now you'll see it's got some different functions. Let me clear these out here. It's got some different functions. This is x1 of t, y1 of t. So that's the first parametric equation. We're going to do the x and the y, and they're different functions, both in terms of t. So for this guy, I want to do, right here is the t squared minus 1, and when I hit my variable button, it used to give you an x, well now it gives you a t. So t squared minus 2, y is 3t, and then I'm going to go to my window on this one. So go to window. I'm not sure what yours is going to be here, but here's my intervals from -3 to 1. So my t min would be -3. My max is 1. I'm going to make my t steps 0.1 to make it smoother. If you do 1, it's kind of a choppy. It looks like consists of a bunch of straight lines. Like if you're playing connect the dots, like the child's picture, you connect the dots, and sometimes it's not real smooth. It's just a bunch of straight lines. On this one, my x min, I'm just going to go by the window here. This looks like -5, so my x min is -5. My x max is 5. I'm going to put these as 1. And then my y min, it looks like I go down to about -7 or so. And it goes up to 6, 7, 8. 8's a little bit off, but those are my 1s. And then when I hit graph, you'll see something like that. And it looks like a sideways parabola. And eventually I could put these together and show that it is a sideways parabola. I can make a function, it would be an x equal y squared situation. But so on this guy, it looks something like that. And if I hit trace, when I plug in -3, I get 7, -9. That's why I told you we could do that by hand. So 7, -9 is kind of off my graph here. I was somewhere in this area. And then as I scan to the right, t is increasing. But you'll see it's coming up this way, going to the left. So -2 would be a 2, -6. So 2, -6, somewhere in this area, down in here. I'm going to go to -1. So -1, -3. As when t is 0, I got -2, 0. And then up in here, when I plug in 1, I get -1, 3. So -1, 3. And just kind of do your best to connect these into a curve. but it's choppy because this is my interval for t. Now this one here is saying change the interval from -2 to 3. So I'm going to go to my window to change that. So my t min, I'm going to make -2. I'm going to make this 3. Hit graph. I'm going to pause the video and save some time. So I'm going to plot this down on the graph. So I went through and I copied some of these points. So it makes this part of the sideways parabola look something like that. But it shouldn't put arrows on the end of it. It stops right there. And then if I go over here from -3 to 3, well, you're probably going to see the whole curve then. So it's going to be the whole thing and not just this part, or the top part is going to be the whole thing. Which we can do that real quick. So -3 to 3, there's the whole curve, and it's shown as much as we can. You can copy that down. Sometimes we can eliminate the parameter itself. So the t we can eliminate and get an equation in the coordinate plane to represent the curve, which would be a function. What we're used to graphing, y equals something x, or x squared, or whatever it might be. So graph the following parametric equations from -infinity to infinity. So when it says -infinity to infinity, you really just do -10 to 10 would probably be enough that it goes off the graph. But I need to go back and change these to 1 minus 2t, and this one to 2 minus t. And again, my window, I'm going to do x and min. I'm going to do the same just because that's what's on my graph. But the t min, t max, this is almost like -infinity to infinity when we're talking about the graph, because that'll probably put me way more than what I can graph. So it looks something like that. So if you copy these points down, I'm kind of speeding things up. So if you want to pause the video and pick them out yourself, I'm copying from my work before, so it looks something like that. So it's linear. It is definitely a linear equation. It looks like it crosses at about, if I was just guessing, so y equals, the slope here is up 1, right 2, and it looks like it crosses y-axis at about 1.5, so I'll put 3/2. Okay, whoops, I write it down, you can't see it. So just by looking at that. Now, let's go through and actually let's eliminate. And this is something we did earlier in the year, so if this looks familiar, hopefully it does look familiar. The best thing, what I want, my answer, y equals 2 minus t. I want my answer to be y equals something, so I'm going to solve x for t. So if x equals 1 minus 2t, solve for t, and then plug it into this one. So on this one, if I subtract the 1 over, it'd be that, and then divide by -2. So t would equal on this, to make if it's a negative on bottom, I don't want a negative on bottom, -x plus 1 over 2 would be t. I'm going to plug that in over here. So y equals 2 minus, then parentheses, -x plus 1 over 2. So this, if I distribute this stuff out, so 2, and it'd be minus -x, so it'd be plus x over 2, and then minus 1 over 2. So putting the x term first, that'd be plus 1/2 x, a positive 1/2 x. 2 minus 1/2 would be 1.5, which is the same thing as 3/2. So they're the exact same thing. Okay. So if you want to eliminate it, take the x parameter and solve for t. I guess t is the parameter, and then plug it in here for that t. Okay. So that'll get rid of the t, and you'll get a function in terms of x and y. Okay, so flip this over, and we want to graph the following parametric equations. So it's x equals 2 cosine t, y equals 2 sine t from 0 to 2 pi. And you might be kind of thinking, from 0 to 2 pi, that's a full circle. And what this is it's like the unit circle, but it doesn't have a radius of 1. So it's basically going to be kind of like that. And this is how you can come up with the unit circle doing this. X has to do with cosine, y has to do with sine. It's going to make a circle when I'm done. So if you want to type that into the calculator real quick here, let's type this in. So let's say y equals 2 cosine t, and then x equals 2 cosine t, y equals 2 sine t. And then I want to go from 0 to 2 pi. I'll leave these in here. That's pretty much the same window, and graph it. Let me check something here. Okay, took me a minute. I figured out what was wrong. I didn't have it in radians because this is in 2 pi radians. Oh boy. So anyway, so graph it, and there's your circle. It does not look like a circle, but if you look, it goes up 2, down 2, right 2, left 2. So it actually is a circle. It's just my scale is off here. So it's right 2, left 2, down 2, up 2. It's making a better circle than I can probably draw. But it's supposed to be a circle. So, and I don't know, you probably didn't get to this last year in Algebra 2, but the graph of this equation looks like a circle, and the equation of a circle is x minus h squared plus y minus k squared equals r squared, where h and k is the center of the circle. In this case, h comma k is 0, 0, because it's centered at the 0. So I'm just going to put x squared plus y squared equals r squared. And if x is 2 cosine t, I'm going to put that in. So 2 cosine t, all of that squared, plus, and then y is 2 sine t. 2 sine t squared equals r squared. Square both of these, so this would be 4 cosine squared t plus 4 sine squared t equals r squared. And then they both have a 4 in them, so factor a 4 out. And if you remember, Pythagorean identity says cosine squared plus sine squared is 1. So 4 times 1 equals r squared, so that means 4 equals r squared. And if you want to write this equation, then that'd be x squared plus y squared equals, well, r squared is 4, so I'm going to put that up here and put 4 in that place. This is actually the function. Now, it's not a function because it doesn't pass a vertical line test, so you'd have to graph it with 2 different equations in the calculator, but that's the function form of it versus the parametric form is up here. We can also write parametric equations for a line. So if I give you 2 points, you could tell me the line that goes through it in a parametric form. So first off, here's how we do it. So you look at point A is -2, 3. So it's right here. There's point A, which is -2, 3. Point B is 3, 6. There's point B, and that's at 3, 6. And what I need to do now is I need to create another point, just another extra point that would be on this line. So say there's a line that goes through those 2 points. So if I continue it on up this direction, I'll put it right here. I'll say this is point P, and I'll just say it's x, y, coordinate x or comma y. What I need to do is I'm going to look at this. I'm going to call this the origin, so that's O. And if I took this vector, vector A, so or say vector OA plus vector AP, that would equal vector OP. So we're going to use vectors to do this. So OP, which would be the resultant of AO plus AP. Well, AP is actually, it'd be a scalar of AB, because it's AB further, being multiplied by something. So we'll let that something be T. So we'll say this is actually T times AB. So instead of AP, we're going to write it as AB times something. That makes it longer. Now I could actually say that this XY is down here somewhere, and that this scale is a fraction and brings it down. It doesn't really, it's hypothetical because I'm not ever going to solve for T anyway. So it'd be AO plus a scalar of AB would equal OP. So start putting in what you know. Well, OP would be, in component form, would be XY, because it's right x up y. AO in component form would be -2 up 3. So notice I'm putting it in vectors. It's a vector. It's not a coordinate anymore. It's a vector. And then this would be T times AB, which AB, in this case, to get from -2 to 3, I had to go right 5. And then to get from 3 to 6, it's up 3. So vector AB, you had to do some subtraction of your own to do that. So how far right and how far up? Distribute that T out there. So this would be -2, 3 plus, and this would be 5T comma 3T. And just the definition of vector addition says that these two add up the x coordinates, that equals x. So x would equal -2 plus 5t, and y would equal 3 plus 3t. And that's actually parametric form right there. You're describing what x is and what y is in terms of a third parameter, t. Now what if I wanted to also write a parametric equation for a line segment? So this is a line. This goes on forever. I didn't put anything down for t. Well, if you want to make it a segment, you're just going to limit what t's you can plug in. So since it's going through, I use the same points to keep this simple. So using example 4, we get the equations. So the equation's x equals -2 plus 5t, y equals 3 plus 3t. And now we're just going to limit what t is. Well, if I want it to be from -2 for x, what would I plug in? So what do I need to plug in here to get -2? So this x, what t do I need to plug in to make it start? So -2 equals -2 plus 5 times what? What t gets my starting point, so it starts at -2. Well, if I add 2 to both sides. Yeah, so this would be 0 equals 5t. So that would equal, so t equals 0. Now double check, does that work with the y? So when I plug in 0 here, I get -2. When I plug in 0 here, I get 3. -2, 3. That's the point where I want to start. So I'm going to let t start at 0, and then where do I want it to end? Well, what would I plug in to make x equals 3? So I'm going to plug in a 3 for x. That equals -2 plus 5t. Add 2. So 5 equals 5t. So t must equal 1. Just double check and make sure that works with the y too. So 1 times 3 plus 3 is 6, and that's the y I want it to end at. So I just need t to be between 0 and 1 to make up this line segment, so it has that beginning and ending point right there. So I'm just going to, same answer, but I got to add the restrictions on t.